Is this here on the cloud? I do believe. Okay, so let's get started on this review. And what we'll do is, again, we'll just do a roundtable. And remember, as you're working on the math sections of the SAT, they really are blocked off sort of easy to difficult. So the first 10 questions are considered, from a teacher's point of view, sort of single 1 or 2 steps. They're the levels 1 to 2. If we rank them from 1 being the easiest to 5 being the most challenging math questions to offer a student, then these first 10 would be like level 1 and 2 questions. Usually, sometimes there's some crossover. They might have 1 challenge question in the mix, but the first 10 are generally easier. So Fiona, can you read question number 1? And I'll put up a blackboard on the other side of the screen so that we can write some notes.
The monthly membership fee for online television and movie service is $9.80. The cost of the viewing television shows online is included in the membership fee, but there's an additional fee of $1.50 to rent each movie online. For 1 month, Jill's membership and movie rental fee were $12.80. How many movies did Jill rent online that month?
Okay, so you should be familiar with linear equations here. So if I write out these notes fast, this is sort of the, it's just written in a different form. So y equals mx plus b, here it's presented to you as the fixed cost first, and then the varying cost, right? So it's not presented in the same way. So every month you pay the company $9.80, and then every movie that then you're free to watch from their library of movies, and it's $1.50 per movie. So how would you solve this one, Fiona?
I would input the total cost as $12.80.
Okay.
And then subtract $9.80 on both sides.
Mhm.
And then divide it by 1.5 on both sides to get X.
Okay, and what did you get for X when you worked this out?
2.
Yeah. Okay, Ms. Fiona, hold on a second. X equals 2. What does that mean? How do we interpret the result once we have an answer? What was the question? How many movies did Jill rent online that month? Fiona says, yeah, she said 2. Okay, so Jill, from that online television and movie service, rented 2 movies. B is correct. Fiona, can you also read question number 2? Another linear equation.
One of the requirements for becoming a court reporter is the ability to type 225 words per minute. Donald can currently type 180 words per minute and believes that with practice, he can increase his typing speed by 5 words per minute each month. Which of the following represents the number of words per minute that Donald believes that he will be able to type n months from now?
Okay, so here's his progress table. He knows what he can do so far. And he said 5. So extracting those important details, I'll just use a highlighter so you can see what I'm saying. Donald what he can do. He's like, well, my hand speed, my skills, 180 per minute. That's really pretty impressive. 5 words per minute each month. So how do you interpret that, Fiona?
Because he currently type 180 words per minute, I think it will be like, the y-intercept, like to represent as B, and 5 words per minute for each month. I would think it will be as MX, so I got C.
Excellent. All right, everyone hear that? The each month is shows that that's the variable term. So that's exactly right. I'll circle that. MX, the variable term, has to do with the 5 each. That's right. And since he's skill building, he's like, I want to get better at this. He will practice. I don't know if anyone plays the piano. I had to practice like an hour a day when I was growing up. You got to sit at the hour, whether I liked it or not. I just sit there on the bench for an hour. But you can develop if you're patient with yourself. You've built here. His goal is 225. That's extra information here. You just need the expression for his, like this is his plan for progress. Okay, I'm at 180 now, plus 5M. Excellent. Okay, very good, Fiona. All right, any questions for Miss Fiona? Okay. So let's go to Gabriella. Can you read questions 3 and 4, starting with question 3?
Question 3. If a 3-pound pizza is sliced in half and each half is sliced into thirds, what is the weight in ounces of each of the slices? 1 pound equals 16 ounces.
Okay,
Should I go right ahead and read it?
Yeah, how would you solve this from start to finish? Yeah.
So you could start by slicing it in half, like doing it like how the problem says, like just following the order.
Okay.
Like first in half, and then
little advice, since the question stems wants their answer in ounces, how can you make that work? How can you
you can convert it right
problem
away.
solving in ounces? Yeah. Go ahead.
Yeah, so it would be 3 times 16.
Exactly. So how many ounces of pizza is that?
48.
It's a lot of pizza. Okay, what do you do next?
Then you can slice that in half.
Okay. So let's do that. We can make it like Sicilian style. Then each side is 24. Okay, then what do you do next?
And then you would each half slice it into thirds, which would that would be
so you got a pizza cutter. So how about
pieces.
this? Oh, okay.
Yeah. And then each piece would be 8 ounces.
Or does that totally make sense if we do it like this way, like 24, and just like you said, then since each of these is a third of the 24, I think that's absolutely right. All right, so here drawing it, maybe drawing it is easier. It's up to you, or if it helps you visualize it, do like a Sicilian, or like, what are they called? Like a deep dish pizza, you know, where they're like, it's like a baking tray, and then boom, and then you got it. So wait, I put down the wrong answer. It was 8.
Yeah, it's 8.
Pardon me. All right, so then that adds up the sum. It's equal to the each slice is 8. So that's an 8-ounce slice of pizza. And that does sum up to 48. Okay, what about question number 4? Very good, Gabriella. What about number 4?
Question number 4. Nick surveyed a random sample of the freshman class of his high school to determine whether the fall festival should be held in October or November. Of the 90 students surveyed, 25.6% preferred October. Based on this information, about how many students in the entire 225-person class would be expected to prefer having the fall festival in October?
Okay, so here's the deal. It's like a random non-biased sample of 90 students, but since it's not biased, it should be the same proportion as if it was the entire student body, right? Everyone who goes to school, 225. So we need to figure out what the numerators will be, but the proportions should be the same. So Gabriella, how do you set up these proportions based on the paragraph?
Well, you could put 25.6 over 90, because you know that 25.6 of the 90 students.
Okay. 25.6%. Okay.
Yes. And then it could be X percent over 225.
Okay. So now we have percents over head count. So then X percent though?
Yeah. Or you could find out how many students would be 25.6.
That would be correct because you want the head count. So you want a good estimate of how many students out of 90, and then that would be in proportion if we that's right. So let's erase that percent. Now you got it. So using estimation, what if I say like 25%? That's like a quarter. That's like a quarter. Then how can we use estimation to get 25% of 90? That should go on top.
You could find a fourth of 90, which would be 22.5, which would be 23.
All right, did everyone see what she just said? Dude, like a quarter, that's a good enough estimate. So like 22.5 or 23 people.
Yeah.
Okay. And then
and then you can
and what?
And then you could put X over 225 and then solve it.
Now you got it. So then if the sample is about 23 out of 90, then now we have X out of 225. So how do you solve a proportion when you have 4 cells like this?
And cross multiply.
Yeah, cross product, cross multiply. All right, so now I'm going to draw the diagonal arrows for class. So this product must equal this product for the proportion to be equal. Well, I'll do the easy side, 90x. And then
90x is equal to 5,175.
Okay, pardon me. Oh, nope. 90x equals 23 times 225. You just use your calculator? I mean, it's the calculator section.
Yeah, 5,175.
5175. Okay, so then divide by 90 and we get?
Yeah, 57.5.
Okay.
So that you could round that to 60, which is B.
B. Okay, that's right, because a quarter was an underestimate.
Yes.
I remember it was 25.6. So definitely round up. Because it should be right, because then you're right. Don't round down to 50. If you're like, oh wait, I just rounded up to 23. Did I round up too high? No, you should 60 should be correct. If we do 25.6 times 90, technically, that is 23. No, you rounded up. That was perfect. All right, yeah, so that's correct. Even 25 is the right way of rounding up because you chose a quarter. So your rounding up was the right idea to do because, sorry, as Gabriella said, that's 25.6. So she rounded up here. So that keeps it consistent. Okay. All right, good work on that. That is mathematically logical. Let's go to the next two. New student, Yale Mendez. Can you turn on your microphone, read questions 5 and 6?
You said read them, right?
Yes, can you read question 5? And I'll help you set up if you're stuck. So
the density of an object is equal to the mass of the object divided by the volume of the object. What is the volume in millimeters of an object with a mass of 24 grams and a density of 3 grams per millimeter?
okay, it's a little tricky, but sometimes what also helps in these science problems is if you write the units. So I'm going to actually do that. So mass, this is grams, and volume, that's in milliliters. So it should make sense when they say grams per milliliter, because that's exactly what the fraction is on the right. Did I write millimeters? Yeah, it's milliliters. It's a liquid. So yeah, how would you solve question number 5?
First, what I would do is, how would I say it? Put in the numbers. For example, I would put 24 and the M, since it's the mass, and the density I'd put as 3 grams. And then what I would do is I would divide 24 by 3 to find the milliliters. No, wait. Yes.
24 belongs in the numerator. We don't know the volume V, but we know this one is a, I'm sorry, say it one more time. What did you get for the volume?
8B.
8B, done. Yeah, you can see that by even by inspection. You're like, oh yeah, then, or you can, right, multiply by B and divide by 3. So 8 is correct. Okay, rearranging variables here. That's right. You have a dV equals M. And so then, since we're solving for volume, when you divide, then you'd get 8 milliliters. Very good. All right, can you also read question number 6?
Last week, Raul worked 11 hours more than Angelica. If they worked a combined total of 59 hours, how many hours did Angelica work last week?
All right, were you able to get this one done?
Yes.
Okay, go ahead.
Angelica worked 24 hours, which would be A.
Okay. How did you do that? Like guess and check, or just?
Yeah, I used guess and check. I just grabbed A, then since Raul worked 11 more hours than her, I added 11, which gave me 35, and then 24 plus 35 would have been 59.
Okay, that's perfect. All right, so then just estimate. So it seems like maybe since it's 59, it should be a number kind of near 30, right? Because it's sort of half and half. But you said Angela worked less hours, so you chose 24. I think that's the fastest way to do it.
Yeah.
Let's say that one more time. I'm going to highlight that. Angela worked less hours because Raul worked 11 more. So he said, well, 24 makes sense. Chose for Angelica. And then by adding 11, the numbers worked out perfectly. That's a time saver on the test. It's probably faster than, that's a really good strategy when you're working because, cut time corners as much as you can. If you write down Raul plus A is 59, Angela plus 11 plus Angela is 59, 2A plus 11 is 59, 2A this is me working as fast as I can, and he's already got it done. Yale's already like, yeah, it was 24. It's like, oh. And then I have to double check my numbers here where I even wrote down 9 instead of 4. But that's it algebraically. But Yale is even faster. Yeah, just made sense. Just made sense to guess and check. Very good strategy there. Because he would have beat me by like 5-10 seconds. He's already on to the next problem. I'm 10 seconds behind now. Let's go to question 7. 7 and 8. Brianna, can you please turn on your mic and read question 7?
The table above represents the 50 movies that had the greatest ticket sales in 2012, categorized by movie type and Motion Picture Association of America rating. What proportion of the movies are comedies with a PG-13 rating?
Okay, parental guidance is suggested, age 13. So for students who are growing up, young adults, it's got a PG-13 rating based on the social issues involved. So I'm highlighting that row. What column should I highlight, Brianna, according to the table, according to the question stem?
Comedy.
Comedies. So I'm going to just put a box around the column for comedies.
Okay.
So what proportion of the movies how do you set up the proportion for comedies that are rated PG-13?
Okay, so first, just add all the numbers that is in the PG-13 row. 14, 8, which is 22. And look at the comedy section, so it's 4 over 22. Divide 2 over 11, C.
Hmm.
Wait, can you hear me?
I'm not, I can hear you. I hear you. You're talking soft, but the, uh, is it all the movies or is it just the PG-13 movies? Here, I'm looking at the lower right corner. From the paragraph, it said that there were 50 movies. I heard you say a different number.
22.
Yeah, how come you were considering only the PG-13? So you set it up like in conditional probability. So the total movies should be in the denominator. And this was comedy with PG-13.
Oh.
Right? So this is it's like A intersect B over the total. It should be like that. So can you set it up one more time? So what is A intersect B? It's PG-13 and a comedy.
So PG-13 and the comedy, so 22 plus 9 equal 30.
So 4, you said? I heard you say it right. I heard you say 4. Then I heard you say a different number for the total number of movies.
No, so the total movies is 50.
50, yeah, that's what I was looking for. Yeah.
And then the PG-13 plus the comedy.
Uh-huh.
31.
Is what?
31,
31?
right?
No, it has to be both on, like at the library. It's got to be a PG-13 movie, but of that list, it's got to be a comedy, right? 10 are action, 10 are comedy, and 8 are dramas.
4.
So how many are comedies and they're PG-13? What's the intersection of the cells?
4.
Yeah, it's just 4 movies like that. So you have only 4 movies to choose from.
So it's A.
So 4 out of 50. Which proportion is 4 out of 50?
A.
2 out of 25. That is correct. So A was correct. Right. So remember to reduce the fraction. So for every 25 movies, 2 are comedies rated PG-13. Can you also, Brianna, very good. Can you also read question 8? That was a two-way table, that last one.
Okay. Line L in the XY plane contains points from each of quadrants 2, 3, and 4, but no points from quadrant 1. Which of the following must be true?
All right. Here you have to either be able to visualize it yourself or just sketch it like in the margin, like let's draw it together. So if I put down the Cartesian plane, where's quadrant 1 in the Cartesian plane, Brianna?
Top right corner.
Top right. Where's quadrant 2?
Below. I mean, yeah.
Do you remember how to number them? Where's quadrant 2?
Left corner.
Left, right. We're going around counterclockwise. What about quadrant 3?
Bottom.
Right, because negative, negative, and then quadrant 4.
The last one.
All right, so as you do more studying in high school, let's say you want to be an engineer. This is the way I remembered it, as being like going to Bronx Science. Like think of it, we're going around this way, like backwards in time, like you're going to make the computer better each time. So when we're going around counterclockwise, it's like we're looking back at this machine that we're going to improve. Like that's how I remember it mentally when I was learning it. Right? So it's just tradition. It's tradition among scientists to go back as we continue to evolve our knowledge, that kind of thing, and make computers faster and stronger, for example, as a basic example. So that's right. So Brianna, if the line is a rigid straight line and it goes the path of the line, like on the map, contains 2, 3, and 4, it's a line like this. I can't put my road here because I'm not allowed to go to quadrant 1, right?
Mm-hmm.
No points in quadrant 1 are on the path, on the locus of points on the line. So I could change the angle of the road like that, but it has to go through all 3. So based on that sketch, now that it's drawn for you, which answer choice is correct?
D.
Can you say it again?
E.
D like delightful?
Yeah.
Yeah, that's a negative slope. It's going down to the right. Remember, we also order space, like positive is to the right. That's right. So that would be, and also up above this ground line here, that's positive and that's negative. So the slope is negative. The rise over the run, right? It's decreasing and that's a negative slope.
Yeah.
All right, any questions for Brianna? That's right. This, whatever the line, if that's the path of the line in quadrants 2, 3, and 4, have to draw it yourself. Okay, make sure you know your quadrants. Let's go to question 9. Another complicated looking table. Okay, thank you, Miss Brianna. Yuko, can you read question 9?
The table above shows the number of registered voters in 2012 in thousands in 4 geographic regions and 5 age groups. Based on the table, if a registered voter who was 18 to 44 years old in 2012 is chosen at random, which of the following is closest to the probability that the registered voter was from the Midwest region?
Okay, so this looks like it's America. And there's no map drawn for you, but how do we, if this is America, how do we find a Midwestern voter from ages 18 to 44? Which row is Midwest? Row 1, 2, 3, or 4?
Row 2.
All right, so I'll just highlight it like that, and we're looking at these states in the country. And then what age in those states?
18 to 44.
Okay.
It's the first and second column.
Thank you. I'm just going to try and cross it with a different color so we can see the intersection. So how many voters is that? If a registered voter is 18 to 24. So this is conditional probability. Here, the total, this is different than, was that Fiona who did that last one? Or was that Brianna? Can't remember. It was Brianna. Here, the total is the subpopulation. So the denominator will only consider the 18 to 24-year-olds. But from that subgroup, we'd set up the numerator. So this is called conditional probability. So with that in mind, what numbers would we write for the numerator and the denominator here? Yuko?
The numerator would be 3,453, and then the denominator would be 14,766.
That's absolutely right. Okay, so for this conditional probability, we're just looking at that subgroup. Okay, so how can you reduce that? Which percent is that closest to? I guess you can estimate.
It's closest to 0.25. It's closest to B.
It is. It's kind of hard to see that, but I guess the best way to sort of estimate the numbers is like 3,500 and 14,000, because if we do that, we get 3,500s and 140,000s, and that's a quarter. So that's the same. If I divide by 5, divide by 35, that's the same as a quarter. If I divide by 5 first, that's 7, over 28, which is a quarter. That's right. So it's choice B. Okay. None of the other percents are close enough to a quarter. Like even though this one is being rounded down, and this one is being rounded up, excuse me, and this one is being rounded downward to 14 when counting by hundreds. That would be correct. Okay, so I rounded this to 35 and I rounded these hundreds to 100 down to 140. But that's B. Yuko, can you also read question 10?
I also read the graph part, right?
Mm-hmm.
A curator at a wildlife society created the scatter plot above to examine the relationship between the gestation period and life expectancies of 10 species of animals. What is the life expectancy in years of the animal that has the longest gestation period?
Okay, what's a gestation period?
Is it like when they're still like in a baby, like the zygote or thingy?
Yeah, when still zygote, when they're still when it's still an embryo before the baby is born, that's the gestation period. With almost all animals on planet Earth, with the exception of maybe the seahorse, that's the mother's job. That's the mom's job, is carrying life for the next generation. It's I think only the seahorse. There might be like 2 or 3 other species where the male plays that role. But as you can see, the longer it takes for the baby to mature, it seems to be. Let's read the questions. You can see it depends on how long. Can you read question number 10?
What is the life expectancy in years of the animal that has the longest gestation period?
Okay, so the longest period animals like are the data over here. So what animal had the longest gestation period? What data point do you see? Here are a few of them in the graph.
The one at 60.
All right, does everyone see that? That's the most extreme. It takes 60 days for this animal study for the baby to be ready to be born. The mother carries it, for example, for 60 days. That's two whole months. Okay. So how long is that animal expected to live when it is here on planet Earth? So 2 months of growth. And how long will that animal, what's its life expectancy?
3 years.
Just 3 years. It is probably not a mammal or a reptile. They don't say what kind of animals these are, but none of them are even living longer to like living over 10 years. But that was question number 10. All right, very good, Yuko. Since even though you've already done 2 questions, can you also do question number 11?
Of the labeled points, which represents the animal for which the ratio of life expectancy to gestation period is greatest?
Okay. So life expectancy will be the numerator and gestation period will be the denominator. So let's set this up. So life Okay, so for these animals, there's 4 of them. There's animal A, B, C, and D. So what are the coordinates here for animal A? And it looks like you're going to have an estimate because they're not on the lattice points. So here's animal A. So about how many days did it take for this embryo, from zygote to embryo to newborn? How many days did that take?
For A, it's about 22.
Okay, very good. And how long does that animal live according to the data?
7.
Live for 7 days. Good. 7 years. 7 years, right? Well, life expectancy is in years. So 7 goes in the numerator. 7 years. And it was 22 days of gestation. Okay, 7 over 22. What's the life expectancy and gestation period for animal B?
For B, life expectancy is 8 years and gestation period is about 44 days.
Yeah, according to what the scientists want to know, we have to do it in reverse. So we're actually doing what's usually the dependent variable first. Right, and what about C?
The life expectancy is also 8 years and
Mhm,
gestation period is about 51 days.
mhm. And what about D?
Life expectancy is 10 years and gestation period is also 51 days.
Okay, so you need to take your calculator and find which ratio for life is best after being carried by this number of days by the life host. So 7 divided by 22, for example, is 0.318. It's not a very and what about for B? Yuko? You still there?
A has the highest.
Mhm. That is ratio of life. That's surprising. So this animal, I'd like to know more about this animal, because whatever the life host is doing in those 22 days, that's a pretty long life in terms of the ratio. Animal A has the greatest ratio of life expectancy to gestation period in this animal study. All right, any questions? It is a wildlife society though, so I mean, maybe it's just, it's a small animal, so it's safer in wildlife. Maybe the prey, it's harder for the prey to get to this animal. I don't know, but yeah, that is surprising. So the only 22 day gestation period and survives for 7 years according to this wildlife study. Very good. Let's move on to the next one. Emily Law, can you read question 12, please?
In the xy plane, the graphs of function f has x-intercepts at -3, -1, and 1. Which of the following could define f?
All right, this actually is a challenge level problem because it's from Algebra 2 class. So this has to do with the idea of analysis. So let me just put 2 pictures on the board. Here's the number line. Here's the y-axis. It says that it intercepts at -3, 1, and -1. So there's a picture like that. So these are known as the zero values, or for zero products. So hopefully that's helpful. So Emily, how do you create a function from the zero values? Means if you plug in these numbers, then the function f of x, which is the x-axis, is the y-axis, should have no height. So if we plug in those values for x, the function should have no height. It should be an intercept. What do you think?
To be honest, with this question, I just looked at it and I already knew the answer. I didn't
Oh,
have
which
to-
one? Go ahead.
I got C.
Yeah, C is correct. Why is it C?
I just plugged in the value, so like -3 plus 3 is equals 0, and I got the x values from there.
Okay, so if it's -3, then when you plug in -3 to this factor here on the screen, I'm highlighting in yellow, that -3, well, that will make, when you do the product, that'll be some number times 0. And like she said, well, if you plug in 1, then this factor will be 0. If you plug in -1, and she said that it's choice C, that's exactly correct. So if you've taken Algebra 2 class, you know that when you have -3, that the factor that must be in the equation is x plus 3, because when we throw that number in, we'll have a 0 in the product. Here, we plug in -1, we need the opposite sign. So that factor must be part of the formula. And here, so that is correct for choice C. So just as an exercise, if we plug in 0, we'll have 0 minus 1, 0 plus 1 times 0 plus 3. This is how you should learn it if you're taking Algebra 2 class. So then that would be, just plug in the number in factored form. It's easier to do the math. We'll have -1 times 3. And that's -3. So that means that the graph that's going around, remember x is like our infinite storyline, but here it's sinking down. Well, since it's a polynomial, it never turns again after there, because if it turned around again, there'd be another, if it turns around again, then there'd be another root, but there isn't. So that means that after 1, it will increase up. Here, it has to turn around to get back to the 0 value. That's, this arc must be here. And then it goes down like that. So that's the right drawing of the cubic. The other way it could happen would be if it was like this. And if the path of the parabola were this way, but that is incorrect. Okay, so it's not this picture. And C is the correct picture. Okay, so if it was -x minus 1 times x plus 1 times x plus 3, it would be this type of curve. Just to show you that she's absolutely right, I'm just going to write down here on the right side the 3 plugins that show that it's a 0 value, that shows that those are 3 star points. Because if this is new math to you, this is how you really solve it. So we'll plug in f of -3. We'll also plug in f of -1. And we'll also plug in f of 1. And you're going to see right now, right in front of your eyes, that because it's in factored form, it shows us that it makes a 0. So we plug in -3, we have, it's exactly what Emily was saying. Then we have these 3 factors. Well, this is a number. This is -4. This is -2. But since it makes a 0 for the 3rd factor, the entire product is a 0. So at -3, when we input -3, the output is 0. There it is on the graph. It's that star point. If we plug in -1, well, then we have -1 minus 1 is -2. The second factor is -1 plus 1. And the third factor is -1 plus 3. Well, what happens then? Then we have -2. The second factor is a 0. The third factor is 2. So Emily was saying, she just said it super fast. She said, yeah. Now we have a 0 in the middle factor. She knows that. So the entire product will be a 0. So when we plug in -1, it'll be at that location. It'll be an x-intercept. Similarly, for the third factor, we have 1. So now we have 1 minus 1, 1 plus 1, and 1 plus 3. So then we have 0 times 2 times 4. So what's cool about, your knowledge of factors, from algebra 2, from analysis, if you can factor an equation, it immediately shows us, even though the arc of this character here, this polynomial, this function that we've written, remember I said, like, if you had a storybook, well, here we see old man Chang and we see him at -3 in the beginning. Then he's out of the story. Hey, he's back in this. He's back later. Then off goes Mr. Chang living his life. And then, hey, we see him one more time, right? So that's the sort of analogy with like a character in a story who comes and goes. Well, for this polynomial here, we see him 3 times with the main storyline, which is the line we're concerned about. How many times does Mr. Chang encounter the x-axis, for example? Oh, there we'll see him 3 times in the story, okay, as he goes along his own independent journey. Okay, so I will highlight it in blue because she nailed it here. She said, yeah, it makes a 0 there, makes a 0 here in the middle. That's what creates the 0 product, and that's what creates these 3 intercept points. So if you like this kind of math, it's called analysis, and you'll study it more in calculus as well. Okay, and you can really then see how certain functions are related to others, have a relationship to others. Okay. All right, who is that? That was Brianna, was Emily Law, right? All right, very good on number 12. All right, I'm just going to red flag this, though, as an Algebra 2 question. So if you're in 10th grade or something, don't be scared by this. That's the idea. Is being able to do that. Okay, so that was question number 12. Okay. Staying with Emily just for one more question. Can you read question 13 about mosquitoes?
The population of mosquitoes in a swamp is estimated over the course of 20 weeks as shown in the table. Which of the following best describes the relationship between the time and estimated populations of mosquitoes during the 20 weeks?
Okay. 20 weeks. So what kind of graph is this? Is it increasing linear, decreasing linear, exponential growth, or exponential decay? You remember those terms for math class?
Yeah.
Exponential. You do or you no?
Yes.
And then the amount final is the amount initial subtracting some rate to the t. So what's going on here? Is it linear growth? Is it the same amount every time we increase 5 weeks? Is it increasing the population by the same amount each time?
No.
It is not. Because if you look on the left, this is how you do it. +5, +5, +5. The left side is skipping by 5s, but the right side is like +900, +9,000, +90,000, +900,000. So this is definitely not linear. It'd have to be the same skip count for both columns. So we can cross off the linear answers. So Emily, how would you describe it? Is it C or D?
Exponential growth.
Yeah, the numbers are growing. They're growing up. So that means it must be a positive rate. We must be adding a % to that 1 so that each time period of 5 weeks it's growing. It's definitely, the numbers are growing larger as time increases. Very good. What's good here is that the writer wrote a evenly spaced timeline on the left. So you can really see that it's exponential growth on the right. Okay, thank you, Emily. Only 20 minutes left. Amin, can you read question 14?
Hold on. The expression above gives the amount of money in dollars generated in a year by a $1,000 deposit in a bank account that pays an annual interest rate of R%, compounded monthly. Which of the following expressions shows how much additional money is generated at an interest rate of 5% than at an interest rate of 3%?
Okay. So, were you able to solve question number 14?
Yeah, I got D.
D is correct? Good. Can you explain why D is correct? What's going on with these two terms down below?
Well, they asked like how much the 5% interest rate was, how much bigger it was than the 3% interest rate.
Mhm.
So I just saw like it was 5 minus 3, like which are the only things that really mattered, and I just chose that to save time.
Right. Does everyone see? That's exactly right. That's perfect. Right. Does everyone see that? Here you put in place R is the rate. So here the bank is offering you 5%. So you can calculate your total amount based on the 5% rate. And then since you want to compare that, you go to another bank. The bank is like, well, we'll offer you 3% based on your investment. Then that would be the difference in the extra amount, additional money. You don't have to solve for that amount. You just have to understand what's going mathematically. That was the correct comparison, was subtraction. That's right. So let's find that in the sentence as Amin said. The additional money. So he's like, oh yeah, that's the difference. And there it is, that subtraction symbol there is the comparison by subtraction. Very good. Amin, can you also read question number 15, scatter plots of real world data?
Which of the following scatter plots shows a relationship that is appropriately modeled with the equation y equals ax b squared, which is, where a is positive and b is negative?
Mm-hmm. All right, so let's put down that there's an exponential model right there. So we have
I got this one wrong. I just took an educated guess.
all right,
I did A.
Y equals, well, A is positive times X to the, like a negative number. So I'm actually going to write negative B. That's the same as A times 1 over X to the positive B. So, oh no, this is a polynomial. Yeah, it's just it's a negative exponent. It's not an exponential equation. All right. So I guess what you need to know is you need to know what a negative exponent does. So let's actually draw a basic equation, and then it'll make sense. You could take your calculator and do this. So if you have a Texas Instruments calculator, like I'm trying to show you on the screen, I hope I'm in my camera view. What you do is you turn on your scientific calculator and you click the y equals button. Then you can enter the equation up above. So what we can do is we can do like y equals 2 times x to the negative 3. right, mathematically, that'll be the same as y equals 2, 1 over x cubed. Okay, but let's see what it looks like to graph a negative exponent. The curve should have a certain shape. And what I'll do is I'll go to Desmos and I'll graph it here. Y equals 2x to the negative 3. So here we go. So you need to explore with your calculator if you get stumped, what with just some basic examples like y equals 2x to the negative 1. Y equals 2, because a is positive, x to the like negative 2. Okay. One more. Y equals 2x to the negative 3. So then just looking at quadrant 1, because remember our data is only like from 0 to 30. Can I zoom out so I can get 30 on the screen? Yeah, it really flattens the curve, really flattens out. So that's the way it happens with in math and science when we have like, you know, there's a pandemic, we get a vaccine, boom, and we flatten the curve, we get it down to almost 0. Hopefully the population will, everyone will be safe. So let me just toggle these graphs. There's the red line. You can see it's coming down in quadrant 1. Well, also if we choose like a negative 2, if we choose B to be negative 2. If we choose B to be negative 3, it starts with some population, right? It's up in infinity, but in the real world, we're collecting data. It's not going to be an infinity. It's going to be, but this is our mathematical model for the data. So it's this kind of shape. Does everyone see that it looks like a water slide or something, like a playground slide? I can't think of a better example. Or like a waterfall, like going to the sea. Does everyone see that? Amin, can you see that?
Yeah, I can.
So that's how you should do it. Just take your calculator, choose a few A values, make sure you can see that, oh, it's that kind of shape in quadrant 1. Let's go back to the test. Which is the only one that you could model if you drew a best of line fit that looks like that sort of waterfall. That basically. Which picture is it?
Sorry,
A,
I was
B,
sharpening my pencil.
yeah.
A B, because it has like the slope.
Yeah, you're totally right. Yeah, that kind of thing, right? So as the scientist, you're like, oh yes, it looks like that could be a good best of line fit for B. This one, no, it's going up like an airplane taking off or a rocket. This one is a cloud. And this one looks like a line. So if I were to mathematically model the collected data, like say Amin is a park ranger and he collects he lives in a cabin and he collects data in the wilderness of anything, the birds, the flow of the water, the air temperature, the air quality, right? Some of it might be linear, y equals mx plus b. This looks like the right model, y equals like 2, ax to the negative b. This looks like y equals ab to the x. It's exponential. And this is no relationship. This is like a random cloud of data. All right, so as you learn more, as you do more science labs in high school, like if you do physics labs or chemistry labs, you'll find that they're depending on the materials and the experiment, you can fit it to a mathematical model to track the behavior, okay, and the behavior change. So I don't think it's linear. I think that definitely B, like he said, it's the only one that kind of looks like that waterfall shape, which is mathematically ax to the negative b. Okay, thank you, Amin. All right, so that's how you do it. If you haven't done best of line fits, remember it's any mathematical like formula we've learned so far. When you collect data, you have to think, oh, which one is it more like a line, negative exponent, exponential equation, or no relationship. Okay, future STEM workers. 16 and 17, let's keep going. We only have 10 more minutes. Dustin, can you read questions 16 and 17?
For what number of days X will the total cost of buying the materials and renting the tools from store B be less than or equal to the total cost of buying the materials and when renting the tools from store A?
Okay, in the other classes that I've taught this, I've done this test before myself. This was hard because there's like, oh, there's a formula above. So students like everyone got it wrong. It's like, oh, you didn't use the formula above. So make sure you read carefully and you see any formulas that are around the table itself. So were you able to solve question 16, Destin?
Yeah.
Or what do you get for this one?
Give me 1 second.
Sure.
I got A.
A. X is less than or equal to 6. From store B and store A. Okay. So how did you compare those two? How did you set up the inequality?
It would be for store A, 750 plus 80x. And then I would set that equal to store B, which would be 600 plus 105x. And then solve for x, which would be 6. And as a result, it's x less than or equal to 6 because at 6, A is equal to B. And we want B to be less than or equal to A.
Oh my God, let me catch up to you. Store A and equal to store B, set up as equals first. Store B 600, 25 for the wheelbarrow, 80 for the concrete mixer. So you go to a store and they have, here's supposed to be a wheelbarrow. It's more like a carriage. So there's a wheelbarrow, you can rent this and they'll charge you 15 bucks a day at store A. So that's for the 15x there. Or if you go to store B, they'll charge you $25. But you also need a cement mixer. Those are cool. They look like tumblers, they look like giant cylinders. Sometimes they have like a cranking arm. You have to crank it yourself so that the cement inside doesn't harden. Or you tilt it. So if you've ever seen them on the street when they're fixing the street, but they have like wheels and you get a cement mixer. Okay. So they charge a lot for that, $65 each day. So I'm highlighting it here. For the wheelbarrow, you got to pay 15 bucks every time you want to rent their cement mixer. They charge you $65. Destin also said, amazingly, he said that fast. He said, well, that's 105. Where'd that come from? Well, the wheelbarrow at store B, they'll charge you 25 bucks. To rent the same mixer at store B, it's 80 bucks. So now, I'll type it all up. 750 plus 80 per day for all those, for both of those tools. 600 plus 105 each day. So just so your workers can work, if you're the foreman or forewoman, that means that you'd, if you went to store A, you'd pay them, that would be the materials cost. And is it per day or per week? Per day, yeah. So there's the equation. Destin, what did you do from here to solve this? Because that's the setup.
I subtracted 80x on both sides.
Okay, so I'll try and highlight that in a different color. So minus 80x. What's 105 minus 80?
25.
Yeah, so 700 equals 600 plus 25x. What do you do next?
I subtracted 600 from both sides.
Okay. So 150 equals 25x. And then divide by 25.
It'd be x is equal to 6.
And then you said, but there's an arrow, then it has to be A or B, but store B will be less than store A. So it has to be this way because we're not dividing by a negative. Store B is less than or equal to A. So the arrow is pointing to the right in this, the way I set it up. So 6 is greater than or equal to X, or X is less than or equal to 6. So it's choice A. That's correct. All right, very good on a tricky problem. Question 17 says, Destin, the relationship between the total cost Y of buying the materials and renting at store C and the number of days X for which the tools are rented is graphed in the X and Y plane. What does the slope of the line represent?
I picked D, the total daily rental cost of the tools.
Very good. So for choice C, again, that's the per day cost. I put these back up. So if we go back to the chart, first, if we had to set up the equation for store C, it would be $700 for the materials like concrete, wood, metal, hammers, nails, staples, whatever, plus the 20X plus 70X. Those are the special tools that you need for the job site. You need a wheelbarrow to move the concrete around, to move the wood and whatever is heavy around by your workers. And you need the concrete mixer for the concrete you bought in your materials. So he's right. That'll be the variable term, the 90X. And that was choice D. Right here at store A, it would be 80 per day. And at store B, if you buy your materials and rent the tools there, you have to pay them $105 per day for the for those two tools. So that's right. That's the daily rental cost for those tools. Excellent interpretation. Those were kind of tough. It was very wordy, and that was question 17. Let's keep going. Who hasn't had a turn? Ivan, can you turn on your microphone and read question 18?
Jim has identical drinking glasses, each in the shape of a right circular cylinder with internal diameter of 3 inches. He pours milk from a gallon jug into each glass until it is full. And the height of milk in each glass is about 6 inches. What is the largest number of full milk glasses that he can pour from 1 gallon of milk? No, there are 231 cubic inches in 1 gallon.
Okay. So I'm gonna have to convert to inches, but I'll kind of draw it. Diameter means the crossing of the circle along the longest chord. So let's see, the diameter is 3 inches. And the height of the glass is 6 inches. The height of the milk. So what's the largest number of full milk glasses? He can pour 1 gallon of milk. So this is 1 glass. So how would you solve this problem if we were to fill it all the way to the top with milk? So how many, how will we find the volume of milk in 1 glass? And then our supply of 1 gallon of milk. Do you have
wait,
with the SAT formula sheet? How do you use the SAT? Should have been the formula sheet. The formulas should have been provided to you on the first page.
Okay, wait, yeah. So I thought it was unmuted. Okay, wait. So I think the height is 6 inches. So that would be the height of the cylinder.
And so what's the formula for the volume of the cylinder?
Radius squared height times pi.
Okay, so remember, if you get lost, well, it's like a column of milk here. This is pi r squared, it's a circle, and times h, right? So V is pi r squared, the base, times the height. It's a column of milk. Okay, what is the radius of this class?
1.5 inches.
Yes, it is. To make the math hopefully easier, I'm just going to write that as 3/2 squared, because we're going to times it by 6. So now can you square the numerator and the denominator? So what's 3 squared?
9.
And what's the denominator?
4.
Yeah, and I'll put this as 6/1 for you. All right, so what do you do next, Ivan?
Oh wait. You multiply everything there, and then you get 54/4 times 5.
Excellent. So 54/4, maybe I'll make that 27/2 pi. So take your calculator, and what is 54/4 times pi? What is that? 54 divided by 4 times pi. So how many cubic inches of milk are contained in the glass?
Oh wait, do you want me to round it?
Yeah, maybe to the nearest tenth should be good enough because we want to.
Okay. So I got 42.4.
Yeah, me too. Okay, so 42.4. So if we have a jug of milk, that's a gallon. So we have a container of milk. Say your mom or dad saying to the store, go get us a gallon of milk. Okay. Then what's 231 divided into cups of, poured into cups of 42.4? How many cups can you pour of milk?
5. So C.
Yeah, 231 is the total amount divided into cups of 42.4. CU cubic inches. I didn't hear you. If you're can you unmute if you're muted again?
Oh wait, I got C, which is 5.
Yeah, you can pour 5 full glasses for you and your loved ones. There you go. 5 glasses. Thank you, Ivan. Very good. So not enough for 6 glasses, but enough for 5 glasses. All right, does that make sense, guys? All right, so that was question 18. Jim's drinking glass. Jim can pour 5 glasses of milk, for example. All right. Boys and girls, we made it to question 18. Very good. Thank you, Ivan. And just keep it organized. Remember that for section 4 especially, before we take a break here, that go back to the first page. Remember to have in your mind's eye, oh, I can use the formula sheet. There it is right there. If you didn't know the formula, V equals pi r squared h. Okay, so don't panic. Remember that there is a reference page. If you can't remember, you're like, oh, it's some type of geometry. Go back to the page, just meditate on the page for like 15 seconds till it clicks, okay? So I know you've been doing some work here. And I know it can be an intense test. So just go back to the formula sheet in section 4. All right, so hang in there as we continue to work on these math skills, and I will see you guys tomorrow. We'll resume with our core lessons, and have a great afternoon. Okay, good work today. Okay, bye-bye.